Good day, students! Welcome back to my channel. Today, you will be listening to my mini lecture about the first lesson of the second quarter in grade 10 science. By the way, this quarter, we will be discussing physics, particularly the topic electromagnetism. In the first lesson, I will be talking about the definition, properties, and forms of electromagnetic waves, as well as the scientists who played an important role in the development of the electromagnetic theory. In this lesson, we want to compare the relative wavelengths of the different forms of electromagnetic waves. But what are electromagnetic waves? Electromagnetic waves are also called EM waves or EM radiation. The letters E and M stand for electricity and magnetism, respectively. Basically, they are created as a result of vibrations, and these vibrations create electric field and magnetic fields. Why do we need to study electromagnetic waves? It is because EM waves or electromagnetic waves are all around us. They are necessary for us to live. Also, most of the technological advances that we enjoy today use EM waves. The sunlight that we need to see things is an EM wave. The heat that we enjoy during the summer is also an electromagnetic wave. The gadgets that we use now for our distance learning use electromagnetic waves. Electromagnetic waves have 7 types, and these types are arranged in what we call an electromagnetic spectrum. The 7 types, as you can see in the diagram below, are radio waves, microwaves, infrared, visible light or visible spectrum, ultraviolet, X-rays, and gamma rays. You can use the following mnemonic for you to remember these 7 terms. Roman men invented very unusual X-ray guns. The first letters of these words would stand for the 7 types of electromagnetic waves. So we have Roman for radio waves, men for microwaves, invented for infrared, very for visible light, unusual for ultraviolet, X-ray for X-ray, and guns for gamma rays. We call visible light visible because it is the only electromagnetic wave that is visible to the human eye. Sa Tagalog, yan lang yung nakikita natin. The rest of the waves are invisible. Also, the 7 electromagnetic waves are usually arranged from long wavelength to short wavelength, that is from left to right, or lowest frequency to highest frequency. This means that radio waves, itong radio waves which is on the left side, they have a long wavelength but they also have low frequency, while on the right side, the gamma rays, they will have short wavelength but they have high frequency. In short, wavelength decreases from left to right while frequency increases, provided that you started with radio waves going to gamma rays from left to right. Now let's move on to the different properties of electromagnetic waves. First, electromagnetic waves are transverse waves. Last quarter, we discussed P waves and S waves, the seismic waves, where you encountered the terms transverse and longitudinal. All electromagnetic waves are transverse. The key term here is perpendicular. If you remember, for longitudinal waves, the movement of the particles are parallel to the propagation of the wave. Here, the movement of the particles or the oscillation of the particles are perpendicular to the propagation of the wave. Next, electromagnetic waves are produced by a moving or oscillating charged particle. When we say charged particle, we are referring to either an electron, a negatively charged particle, or a proton, which is a positively charged particle. So if that particle is at rest, ibig sabihin hindi gumagalaw, it will produce an electric field because it is an electric charge. However, if that particle moves, once that particle moves or vibrates or oscillates, it will start to produce both electric and magnetic fields. So itong electric at magnetic fields na to, magko-combine yan and they will produce an electromagnetic wave as you can see in the GIF on the screen. So here we can see that the blue part is the electric field and the yellow part would be the magnetic field, and they are perpendicular to each other. Third, they do not require a medium to propagate, and they can travel at a speed of 3 times 10 raised to 8 meters per second. Now let's try to break down these statements. First, they do not require a medium to propagate. Okay? They do not require a medium to propagate, but it doesn't mean that when there is a medium, hindi na sila makapag-propagate. It's just that hindi na nila required na magkaroon ng medium para sila ay makagalaw from one place to another. Why are we stressing this? Because if you remember in grade 7, we have what we call a mechanical wave. A mechanical wave requires a medium to propagate. Kailangan niya ng medium. Yung electromagnetic waves, hindi niya kailangan. So, kahit meron o walang medium, makakapropagate si electromagnetic wave. Ngayon, ma'am, ano ba yung medium na sinasabi po ninyo? When we say medium, we are referring to a solid, a liquid, or a gas. So, if you have a solid, liquid, or gas, and you have a mechanical wave passing through it, a mechanical wave can pass through them. An electromagnetic wave will also pass through them. However, if you have totally nothing, you don't have a solid, you don't have a liquid, or you don't have a gas, hindi na makakadaan sa kanya si mechanical wave. Pero, si electromagnetic wave, kaya niyang dumaan because it does not require a medium to propagate. By the way, the term we use for totally nothing or no medium at all is vacuum. Next part of this property, they can travel in vacuum at a speed of 3 times 10 raised to 8 meters per second. So in your screen, you can see a pictorial representation of the comparison of some speed samples. However, the units here are not in meters per second kasi m/s is meters per second. Okay, here the speed is in kilometers per hour and miles per hour. However, you can see how fast that speed is we are referring to. So, light is the fastest, it is the highest speed possible. Yung speed ng light sa vacuum, it is the fastest speed possible, and scientists haven't discovered any object or any entity that can surpass this speed. Yun ang pinakamabilis. So, fastest runner, ganyan lang siya kaliit. Okay, around 43 kilometers per hour. And then, even the cheetah, compared to light, napakalayo ng difference. Now, how large is 3 times 10 raised to 8 meters per second? 3 times 10 raised to 8 meters per second in standard notation would be 300 million meters per second or 300,000 kilometers per second. Ba? Kapag kayo ay naglalakad, ang isang hakbang ninyo ay hindi naman siguro aabot ng 1 metro. So, ang lakad natin is roughly 0.5, 0.8 meters per second. Normal walking yon. So, how fast would be 300 million meters per second? It would be very fast. Gaano kabilis? According to Google, the distance between the Sun and the Earth is 147.13 million kilometers. Now, using the formula for speed, which is distance over time, we are given the distance from Sun to Earth, and we also are given the speed of light because light is coming from the Sun going to the Earth. If we use these values, we will arrive at this time. It would take approximately 8 minutes for sunlight to reach Earth. So, considering the distance between the Sun and the Earth, it will still take a few minutes for the sunlight to reach our planet. Next, the speed of electromagnetic waves changes depending on the medium where they are passing through. A while ago, I mentioned that when we say medium, we are referring to a solid, a liquid, or a gas. Here in the screen, you can see that the speed of light in kilometers per second, these values will vary depending on what type of material the electromagnetic wave is passing through. Whether it's solid, it's liquid, it's a viscous liquid just like oil, it's a glass, or a different type of solid, mag-iiba yung kanyang speed. And generally, as you can notice, as the solid or as the matter becomes more compact, the speed of light decreases. So we call this materials optically denser, itong mga nasa baba, because they are able to slow down light or electromagnetic wave compared to other materials. Now, why are they being slowed down? It's because of refraction or bending. The more dense or the denser the material, the higher the tendency for these electromagnetic waves to bend or to refract. Kaya meron tayong tinatawag dito sa kanan na index of refraction. Now, let's go on with the qualitative description of the wavelengths of the types of electromagnetic waves and a brief description or brief explanation of their applications. So, a while ago, I have shown this to you. Okay, this is a good representation of the different electromagnetic waves. On top of this, you can see the different applications. So, as we can see here, radio waves would be used in, of course, radios, AM, FM, and then microwaves would be for cell phones, radar, and so on and so forth. I have here another diagram of the electromagnetic spectrum, and it also shows us the relative sizes of the wavelengths. I told you last time that the wavelength of radio waves would be longer than the wavelength of a gamma ray. Okay, so saan ba natin may kukumpara itong mga wavelength na to? The wavelength of a radio wave can be as tall as a building, while the wavelength of a gamma ray can be as small as a subatomic particles. You can see the difference of the wavelengths. Here, they can be compared to a baseball, to a pinpoint, to a bacteria, viruses, and atoms. Also, here in this diagram, the major applications of the electromagnetic waves are shown. Usually, the electromagnetic waves on the right side, which are of higher frequency but of shorter wavelength, are used in the medical industry. But we all know X-rays, you use that for imaging kapag kayo ay nababalian ng buto or kapag gustong makita kung okay ang lungs, we use X-rays. Also, if you know CT scans or other imaging na better dun sa X-rays, they use gamma rays. So, gamma rays can also be used for treatment of cancer. Infrared, ultraviolet, and visible light, these are three types of electromagnetic waves that can be produced by the sun. So, yung init na nakukuha natin sa araw, infrared yon. Yung liwanag, that is visible light. And yung medyo harmful naman, na nakakapagpaitim talaga sa atin, that is the ultraviolet. Okay? Pero marami pa yung mga applications. Not only that, they will be discussed in the next weeks to come. Microwaves, of course, that is used in an oven and also in cell phones, also in radars. And for the radio waves, okay, this is used for radios, yung AM stations, FM stations. They are using radio waves. So now let's go to the different scientists who played an important role in the development of the study of electromagnetic theory. Let's start with William Gilbert. So William Gilbert in 1603 discovered that the earth was magnetic and theorized that electricity and magnetism are not the same. So to honor him, the unit for magnetic potential Gilbert was named after him. Next, we have Charles Augustin de Coulomb in 1785 who formulated what we call the Coulomb's law. So Coulomb's law relates the forces in between two charges and the distance in between them. So meron tayong tinatawag na attraction and repulsion. Remember, like charges repel, opposite charges attract. This is similar to magnets because like poles repel and opposite poles attract. Because of his contribution, the standard unit for charge, coulomb, was named after him. So next we have Hans Christian Ørsted. So in 1820, 'di ba, halos 200 years yung lumipas. It was Hans Christian Ørsted who finally discovered the relationship between the two fields. Kasi before his time, electricity and magnetism are two different fields. However, he accidentally discovered that electricity could produce magnetism while he was teaching his students. Meron siyang electric circuit na dinidiscuss sa kanyang mga students during that time, and he also has a magnetic compass. So, the magnetic compass, as we all know, sa mga, siguro meron na sa inyong mga nakahawak na iba ng ganyan, it has a needle that moves whenever you move kasi it follows the direction of the poles of the earth. So, he placed that magnetic compass in his table kung hindi yan gumagalaw, and whenever he switched the circuit on or off, nagkakaroon ng slight movement. The question is why? Because sabi ko nga kanina, 'di ba, hindi gagalaw ang needle unless you move the magnetic compass. The compass is just on his table. So he discovered there that electricity could produce magnetism. Next, we have Joseph Henry. Joseph Henry in 1831, is around a decade from the discovery of Hans Christian Ørsted, discovered electromagnetic induction, which is basically the reverse of what was discovered by Hans Christian Ørsted. Remember, Hans Christian Ørsted discovered that electricity can produce magnetism. So Joseph Henry discovered that magnetism can produce electricity. And in honor for his contribution, the standard unit for inductance was named after him. Okay. However, in your module, merong isang tao na hindi nabanggit. Pero for me, mas kilala siya compared to Joseph Henry. The problem is that they discovered the same thing at the same time, independently. Hindi sila magkakilala, magkalayo sila. Pero na-discover nila almost the same thing, which is electromagnetic induction, and that is Michael Faraday. So Michael Faraday also discovered electromagnetic induction, which again is a production of electricity from magnetism. Next, we have Wilhelm Edward Weber, who discovered that the ratio of electrostatic to electromagnetic unit equals the value of the speed of light. So from this, he discovered that light is an electromagnetic wave. Another unit was named after him, which is the unit for magnetic flux. So next, in 1861, is James Clerk Maxwell, who formulated four equations which summarize everything about electricity and magnetism. We call these equations the Maxwell's equations. As you can see now, we have 4 equations here. So what I'm showing you, they are written in differential form, but there is also an integral form. So both are in the language of calculus. So dito makikita natin na may mga names yung bawat mga equations, and you will notice in number 3 we have Faraday's law. So this is the reason why I also included Michael Faraday in the list of the scientists who contributed in the history of electromagnetic wave theory. Sabi ko nga kanina, Michael Faraday is actually more famous than Joseph Henry. And another thing is that yung pag-aaral ni Faraday, yung mga study niya, yung iba doon ay pinagbasehan ni James Clerk Maxwell para magawa niya tong mga equations na to. Actually, Faraday was mentioned a few times in his book where he published or where Maxwell published these 4 equations. Next, in 1887, we have Heinrich Hertz, who proved the existence of radio waves through his experiments. You can remember that the unit for frequency is hertz. Finally, we have Albert Einstein in 1905, who formulated the concept of photoelectric effect. So in this study, Einstein won the 1921 Nobel Prize for Physics. The photoelectric effect is the emission of electrons when electromagnetic radiation such as light hits a material. So, although Albert Einstein was also well known for his theory of relativity, he won the Nobel Prize for this study. So that's all for the history of electromagnetic wave theory. I hope you have learned something from this discussion, and thank you for listening. Bye!